Here we are. Hello to everybody. We just wait some additional minute to see if others are joining, and then we will start. Yeah, I think we can start our webinar. So let me go to the presentation. Some additional minute. Okay, then. So I am Enrico Bullian. I am the general manager of RF System. And today I'm going to introduce you and present our webinar about the radio frequency in defrosting. You can contact me at my mail, bd@rfsystem.it. Let's see if somebody is coming. We are a good number of people today. So, first of all, why this webinar about radio frequency defrosting? By my experience visiting our distributor and client worldwide, I see more and more that there is a high request of frozen products, and there is a worldwide shortage, for example, in meat industry, and I see more and more company adding frozen meat to their production, to the fresh meat. So for those of you that have not yet included frozen meat, this should be something to consider. Another reason why to speak about this technology is that for those of you that already defrost with other technology or with no technology with natural defrosting, you should be concerned about bacterial proliferation when we are talking about a very long time for defrosting. And another aspect to be considered is the process of sterilization in time of workflow and workforce that is needed when, for example, you need to plan in advance to take out of the freezer your products and plan in advance the work of the people. Last but not least, the cost reduction, because you will see that with this technology, you can save the economic loss of the liquid loss, the drip loss, and you can have energy saving because this technology is very efficient. Let's see now which is our short agenda. By the way, this video will be recorded and you will receive a copy of the slide that I'm going to present. I will shortly introduce our company, RF Systems, and then I will explain you how this technology works. And I will compare it with other conventional systems and telling you which are the advantages of using the radio frequency defrosting. Then we will end with some conclusions, and I will leave you to make your question. You can do them in any time. You can use the answer button and write down your question. I will try to answer all of them. I hope there are many. So, speaking about us, we are based in Italy. We were born back in 91, so we have more than 33 years of experience. And we manufacture heat treatment using radiofrequency technology. So let's speak about the technology now. And starting from this basic consideration, as you know, all of you know, of course, any product, any food product has water inside, even if it were talking about a dry product. And water, as you know, are made of hydrogen and oxygen, and therefore they are charged molecules, which means they have a positive and negative charge due to the hydrogen and oxygen charge. So what happens if you put under electrode, which are charged electrically, a product like a steak, a piece of meat, a block of meat? The water dipole will follow the field and the polarity of the electrical field. Therefore, they will orientate in the same direction. Now, in our system, in radio frequency, we alternate, we change very frequently the orientation of the electrical field at 27 times million, sorry, 27 millions per second. This is the frequency of our system. So when you change the polarity, the water molecules will rotate. And as you know, heat is the rotation, let's say, the movement of molecules inside a product. So by friction, we induce this friction into the molecules, and therefore we create a heat. And this is a very efficient way of creating heat, because, as you can understand, we are not touching the product with a heat source. We are not transferring the heat from outside to the inside. We are creating internally the heat. In English, in fact, this technology is called volumetric heating or dielectric heating. The term dielectric heating comes from dielectric property of any substance that has different property of absorbing the electrical field. Now, radio frequency is not a radioactive technology. As you can see, our frequency is way below the visible light. And we are in the radio broadcasting frequency, the same of your cellular phone, for example. So we are not talking about ionizing radiation like the gamma rays or the X-ray. We are talking of a frequency which is way below, for example, the microwaves. And therefore, is not risky for the operator, and it is not risky for the product as well. In fact, way below, you can see a link to the Food and Drug Administration, who consider this technology a normal heat treatment where it is not needed any certification or process to use it. It's considered a normal heat treatment. Now, speaking about conventional heating, I would like to explain you the main difference. As you know, in conventional heating, the heat go from the outside of the product to the inside. Therefore, you will have, for example, bacteria proliferation on the surface of the product because it will be already at positive temperature while the inside of the product will be still iced. And therefore, any conventional heating system has the following disadvantages. First of all, a very long time compared to our technology. Secondly, the bacterial proliferation, because the moment that the surface reach positive temperature, you will have the bacterial proliferation. And third, the drip loss, which is the loss of liquid of the product when is defrosted using a conventional system. Another technology, which can be considered similar, but it is not really, is the microwave. In microwave, as you can see from this diagram, you have the waves that are generated by the magnetron, and through a waveguide, they are injected from a single point into the chamber. And you will have this situation. The wave will bounce between the product and the chamber like a ping pong ball, resulting in heat absorbed by the chamber itself. So part of the energy that you provide to the system will be dissipated in heat in the chamber. And then, as you experience from your own microwave, the product is in a rotating table because it is a random situation where the field is not uniform. And another point is that because the microwave are very short, they are not able to penetrate deeply into the product. In the case of our frequency, which is 27 megahertz, we are able to penetrate a very thick block of meat, 25 centimeter high, for example. And theoretically, our waves are able to penetrate deep in 1 meter of product. So the disadvantages of microwaves are less penetration compared to radio frequency, the creation of hotspot, because there is a tendency of the surface to run away, meaning to increase the temperature, as we will see in a short time. And last, as I explained, there is an energy dissipation due to the fact that part of the radiation is absorbed by the chamber. This is the diagram of a schematic diagram of a radio frequency defroster system. And we see that the product, the red blocks, are inserted into the chamber through a conveyor, and they are below the electrode. So a very uniform electric field will pass through the product, and the product will be heated in a very uniform way, resulting in a very uniform product, a very fast defrosting, and a very efficient heating. Because, again, we will not have any loss of energy. If you touch the conveyor, it will be cold. If you touch the machine outside the chamber, it's not heated. We are not going to heat air or water like in conventional systems. Therefore, there is a very high efficiency in the transmission of the energy. And by the way, the machine doesn't need to be preheated and is consuming energy only when the product is under the electrode. Otherwise, there is zero consumption. In this diagram, you can see the comparison between the blue line, which is a conventional system that can take from 12 to 24 hours to defrost uniformly. We are talking about big blocks, for example, 25 kilograms. And under the radio frequency, in just half an hour, we can defrost such a big block in a very uniform way. In this diagram, I try to give you a map how to select different technology for defrosting and comparing each other. So on the horizontal axis, I put the process time, how fast it is the technology to defrost the product. We can divide from a very slow process to very fast one. And on the vertical axis, I put the thawing quality. For example, we can consider as a dimension for quality the uniformity. So non-uniform defrosting against uniform defrosting. And guess what? First of all, we are talking about external heating technology. The worst case is natural thawing, which means you just take your product out of the freezer and you leave them there waiting to reach positive temperature. Very slow and not uniform. You can use a tumbler, which will be for sure faster and more uniform, or you can use a defrosting chamber. But these conventional systems are all giving you a very long process and a non-uniform one. The winner in speed is the internal heating technology, the volumetric heating, and microwave for sure is the winner in speed, is the faster technology, but is not as uniform, as I explained before, as radio frequency, which is the best solution to achieve very fast defrosting and uniform quality. In this diagram, you see the difference of the surface temperature between a product defrosted with radio frequency, the orange line, and with microwave, the blue line. What happened at the surface is that due to the fact that the microwave has a higher frequency, we're talking about, for example, 900,000 megahertz, we have this situation. After, let's say, 15 minutes, the surface will start to increase the temperature. And as soon as we have the changing phase from ice to water, the water on the surface will run away, means will increase the temperature starting to boil, and therefore you'll have hot spot. The product will change color, will start to cook outside. And this is very difficult to control. Besides, in radio frequency, because we are using a lower frequency, it doesn't happen because the dielectric property of the product change with the frequency. So at our frequency, we don't have this problem of thermic runaway of the surface. Now, what you can do with the radio frequency in the food and food processing, not only defrosting. In fact, with the same technology, you can dry any kind of product. And for example, in bakery, it is used for post-baking application, where you need to level the internal moisture of baked product without overburn the surface. This means a reduction in acrylamide formation and a longer shelf life because of the reduced water inside the product. The same technology can be used for pasteurizing. Again, for bread loaves, we can extend the bread shelf life because with this thermic treatment we can very uniformly and very fast and very deep kill bacteria and mold. in agricultural commodities, we can use this technology to kill insects, larvae, and eggs. So with a sanitization of infestant. Then, of course, we can use this technology for defrosting. And which kind of product you can defrost? Basically, any kind of protein, no matter if it is meat, fish, poultry, but also vegetables, dairy products, and fruit, which can be even IQF. Now, let's see which are the advantages of this technology compared to the conventional one. Like we said at the beginning, time reduction. For those of you that do not use any particular technology, you know that it will take 24 to 48 hours to defrost a thick block, for example, of 40 by 60 by 20 centimeter of meat weighing, for example, 25 kilograms. With our machine, on average, we go from 20 to 30 minutes. It can be even less if the product is smaller. So this fast defrosting technology, first of all, allow you to save the liquid loss because it's so fast that there is no difference between the outside and inside temperature. The liquid loss is 0 or maximum 1% compared to normal conventional technology where our client tell me that they can have a drip loss even up to 8 to 10%, depending on the products, of course. And another consequence of the speed of this technology is that because it is faster, it reduced drastically the proliferation of bacteria, especially at the surface of the product, and so maintaining the organoleptic property of the product and the safety and quality of the product. Another aspect, which is very interesting, is that you can defrost the product in the original packaging. So no matter if you have a cardboard or a plastic or both packaging, you don't need to take the product out of the packaging. And this will save you a lot of work and will simplify the workflow. But also will protect the product. Think about, for example, I always this example, if you have to defrost octopus, you will destroy the octopus if you will use a tumbler, for example, you will obtain a soap. Beside, with this technology, you can defrost the product in the original packaging without touching them and preserving their mechanical characteristics and also the quality. You cannot even reduce the stock in your freezing room because you can defrost just in time the quantity that you need. And another big advantage that our client always remind me is that instead of planning one day in advance all the quantity you need for the day after and taking out from the fridge with a team of workers, you just need one person that can take the product from the refrigerator area to the machine and one to take it out just in time, so simplifying the logistic. The machine starts from an envelope of 4 meters with a capacity of 300 kilograms per hour, and the biggest system arrived to even 6,000 kilograms per hour of defrosting capacity. And therefore, the space occupation of the system compared, for example, to a defrosting chamber is limited, so you can even save time. And then, as we said, because there is no dissipation of heat in the air, in the water, in the machine, the system is very efficient, and it is green because it is not using, for example, a gas burner, and so it's not using fossil fuel, and it has a neutral carbon dioxide emission because it's using only electricity that, for example, in your factory can be produced using electrical panels. Let's see some example of application. Here you can see some picture from our clients, defrosting fruit, vegetables, or in the picture on the left, for example, fish in their original packaging that, as you can see, can be layered one above the other. Of course, you will need more time in this case, but it's possible to layer products above each other. And on the bottom right corner, you can see another example. You can put your product on a plastic tray and put it on the machine. So we are at the end of my webinar, and I would like you to go back, reminding this basic point. With this technology, if you are not using already frozen product, you can consider the use of frozen product in an easy with an easy system that will allow you in a very short term to defrost the system with few workers. And if you are already using other technology, you should consider the improved quality that you can have with this technology because of the lower bacterial proliferation due to the very fast defrosting process. You should consider also that for your operation, you can increase the production capacity of your company only with this system, because of course it will speed up the defrosting process and will give you much more flexibility to increase your productivity. And last but not least, this technology will allow you to increase the yield because of the reduction of the drip loss, and it will also make you save money in energy consumption. So I am at the end of my presentation, and now I see if some of you had some question. Let me check. Okay, there's one question. Can you repeat the smaller capacity and higher capacity in size and kilogram in time? Okay, the time is not dependent on the capacity. So on average, a block of frozen meat, for example, can be defrosted from 20 to 30 minutes, depending on the size of the block. The capacity of our system starts from 300 kilograms per hour, but can arrive to 6 tons per hour. In this case, we have a machine in line that are able to defrost this kind of quantity. So at the moment, I don't see many other questions. Okay, sorry, I didn't start from the beginning. Okay, there is one. How thick can the packaging be? Well, there is not a limit because plastic and cardboard are neutral to the electric field. So there is not a limit in the thickness of your packaging. The only limitation is metal. So, but I doubt that you will have any protein or vegetable fruit in metal container when you are freezing them. So there is no limit in the thickness. Okay, there is a question about the required power outlet for radio frequency machines. Depends on the production capacity. Before I told you that we have the smallest equipment with a production capacity of 300 kilogram, and it is a machine with a 7 kilowatt radio frequency power. The biggest machine that we have has the production capacity of 1.5 ton, and it has 75 kilowatt power at radio frequency. Of course, we can put this machine in line in parallel and achieve 6 ton per hour, as I was explaining you before. Just to give you more details about this question, on average, the energy consumption of a radio frequency defroster is between 30 to 50 kilowatt hour when you are raising the temperature of 1 ton of product from, for example, minus 20 to minus 4. There is another question. Height of the entry can be according to the product. Okay, we have a maximum opening of about 300 millimeter, 30 centimeter. So I think that most of the product and the standard, let's say, tray will pass through the machine. So in a very special system, we can increase this height of the opening, but most of the case is more than enough to defrost any kind of product. Yes, I will. We will send you the presentation at the end. You receive the slide and also the video. Let me check if I miss any question. Okay, there is one here now. How can we determine the time necessary and so the conveyor belt speed to defrost the product? Can we calculate it, or we absolutely have to do some test? There is something else. Does a formula or diagram to determine the defrosting time considering the type and dimension of the product defrost? Okay. When we install a machine, our technician will come and adjust the parameters depending on your production. So the machine has a PLC, and we store in the PLC all the recipe for your product. So if you have a different kind of chicken, for example, to defrost, you have a breast, but we have legs. Each one will have its own recipe, and we store it. So we can modify the recipe, modifying the speed and the voltage applied to the electrode and the distance of the electrode from the product. Our technician will teach your operator how to create a new recipe, and in any case they will be stored, and of course they are protected by a password so that anyone can tamper and modify them. So of course there is a relationship between the dimension of the product, the final temperature, and the best, there are diagrams, but the best is made out of experience and by testing the final temperature at the end. So once you have set up the parameters, the machine is very consistent, which means that will give you always the same result. There is another question. What is the required? Okay, already answer. Can you use the same system for defrosting and decontaminate? Okay, if you are referring to the pasteurizing and sanification that I mentioned before, these are different systems that use the same technology. For example, when we need to pasteurize a product, we need to make sure that we will keep the pasteurization temperature for at least the same time that we increase the temperature in the radiofrequency module. So we add to radiofrequency a chamber to maintain the temperature. So let's say the technology is the same, but the system is less different. Can you repeat the small capacity? Okay, already answered. How thick can be the package be? Already answered. Do operators need special protective equipment? This is important. They do not, because, as I said, this is not considered a special, let's say, technology, and it is not a radioactive technology. Is a normal electric field of the radio broadcasting. So there is no any equipment that the operator need to use for this technology. There is another one. How can I achieve positive temperature after radio frequency towing? Most of our clients usually ask us to keep the cold chain, so they go out at between -4 to -1. Some of them, for example, they mix the fresh meat with the tow meat, and they have a positive temperature mix in this way. But other just leave the product out to reach the positive temperature, or for example, they use the frosting chamber to reach the positive temperature. So you have many different ways to reach positive temperature. I already answered about the energy consumption. So I think if I didn't miss anybody, I answer. Okay, there is one. Okay. No, but I see there are many. Let's see which one I haven't picked up. Spreadsheet for calculation the minimum size according to product parameters and specification. Yeah, this is something that our distributor will do, and of course we do when we have to dimension the right equipment for your application. Is there any chart of cost comparison between microwave and this technology? Well, what I can say you is that microwave, as I explained, has let's say lower overall efficiency because there is energy dissipated in the chamber. And so the operating cost will be, for this reason, higher than the radio frequency machine. The second aspect to consider when comparing the cost related to radio frequency and microwave is that the radio frequency generator has a very long life. Generally, it can last 15,000 to 20,000 hours, which means 5 to 6 years of fully operation. In a microwave, the magnetron has a shorter lifespan, probably about 5,000 or less hours. So many clients need to replace the magnetron every year or even six months. Another one, should the use of this technology be indicated on food labeling, for example, as any other product? No, absolutely not, because this is not a, irradiation. This is not considered, and it is not a irradiation technology. It's a normal thermal treatment. Okay, so thank you for all this question. If you have additional request, you can email me at bd@rfsystem.it, and you can even find me on LinkedIn. My name is Enrico and last name Boolean. And yeah, I'm happy that you participate to this webinar, and looking forward to receive your additional request. I'm available. And of course, in our facility, we do have a lab where we can do for you the test and invite you here, or invite to see our client, some of our client that will show you the advantage of this technology live. Thank you for your participation.